So in the last lecture, we did the projectile motion. If you have any doubt, you can ask. Then I'll move to the next topic, which is relative motion.
Still, in ALP question number 9, they have not mentioned any speed.
Just let me check. Hmm.
So do we take the same velocities or different?
Okay, just can you share the question?
Okay, wait, I will send you a program.
Okay, I think I got it.
They have not mentioned same velocities or different.
Question number 9.
9, yes.
Okay. So it must be opposite, right? I mean, it's a different value.
But then we will have to assume U1 and U2, right?
No, if you don't assume different,
Because then on basis of U1, U2 will get different heights, right?
yeah, different
So
horizontal
I
displacement.
was thinking that since shots were fired simultaneously, so
Yeah.
I was assuming that they both are the same, then so same velocity kind of
No.
like that.
If you assume
Okay.
same velocity, problem is with same angle you can't have same horizontal components. So they
No,
will
there
never
are different angles, right? Alpha and beta.
Yeah, so the component will change, na? So with a different horizontal component, they will travel different distance in the horizontal.
Different, yeah, that's what I was having problem with. But okay, then in answer, I guess they would have given two values,
Yeah.
U and V. Okay.
Yeah, so you have to take it different. There is no way out.
Then we can solve it. Yes.
Yes.
So, and since both of them will have the same time period, right?
Yeah, so V1
Because
cos alpha must be same as V2 cos beta.
Then we can solve. We got the relation between them.
Correct. Okay. So anyway, today we are going to see questions like this again in relative motion also.
Sir,
Yes.
I had a doubt in part 3 of exercise 2, multi-correct.
Part 3. Just a minute. Part 3, question number?
The last one. Yeah, answer given is, it feels wrong.
No. If you think in terms of energy conservation, all will have same kinetic energy in the beginning, same potential in the beginning. So when they hit the ground, they will have same kinetic energy again, and speed will be same, velocity will be different.
Okay.
Think in terms of energy, no? It's very simple.
Okay.
So no matter which direction you shoot or project, the energy is only this much. No?
Yeah.
And if height is mgh, so let's say this is u. So when you hit the ground, it is mv square only. So v is fixed, no?
Yeah. Okay.
And that's why I said, like, when you're solving the question of projectile motion, make use of all three ideas together: component, energy, and of course the vector. So you have
I
to
get-
always figure it out that the most, optimal way of solving.
I guess I was thinking in terms of perpendicular components only to find this like striking speed.
No, speed means you have to find the vx and vy both, right?
Yeah. Got it.
So if you add v, if you want to find v, then you have to do this, right?
Yes.
And when you do this, let's say this is ux square, and this is becomes uy minus gt whole square, let's say. And if you do so, what will get? Ux square, uy square minus 2uy gt.
Yes.
And I think you can find this will become what? This will become u square.
Hmm.
And then 2uy gt. So the speed will be this much.
Yes.
And once you substitute the t value, so t depends on y only, right?
Yeah.
So the uyt minus half gt square. I mean, it's like a h plus uyt equals to half gt square. So basically, uyt is also half gt square minus h. So this will get replaced, right?
Yes.
So 2g into half gt square, right? And you can see this gets cancelled, and this becomes what? G square t square, right?
Yeah.
And this is 2h, right? 2h. I mean, you have to substitute this value
Yes.
into sorry, or you can say plus gh, 2gh, right? So you can see this gets cancelled, and then you have answer u square plus 2gh. So in a way, it is going to be independent of the component, right?
Yeah.
Even if you would have solved that way, you would have got the answer.
Okay. Understood.
Okay.
So then comprehension part, the third question of comprehension one.
The maximum height attained by the ball A from the ground. Which question is it part of comprehension, right?
Yeah.
And what is A part? A part is the first diagram,
The ball is the first one. Yeah.
and the collision is perfectly elastic, right?
Yes. In all cases.
So when when you hit a surface at horizontally, so the vertical component remains unaffected.
Yeah.
And so your time of flight and maximum height will be same.
Yes.
So the height that you would have attained otherwise will be same here also. But in the case 2, it will change because you cannot go further up.
Yeah.
Your y component is getting reversed. I mean, kind of changed. Okay. So in the second case, the x and y component both will change.
Yes. Sir.
And same is with the C option also. The x and y component will change both.
Hmm.
Because the impact is that way. But because it is hitting perpendicularly, so you will just retrace the path. So for every normal hitting, it is like the law of reflection.
Yeah.
Because it's perfectly elastic, so the light will retrace the path if it is hitting perpendicular.
Yes.
So similarly, in each case, it will retrace the path. Okay.
Sir, but
So-
like they've just given the time of flight. They've not given the velocity or the height or anything else. They've asked to find the maximum height
Maximum height.
attained. Yeah.
So it will retrace the path. So maximum height is the point of hitting only. I mean,
Yeah, but
in the
they've not
first
given
two cases.
anything. They've not given anything except the time of flight.
No, that is sufficient. No? If they have given time of flight, so You can draw like this. Okay, this is the second case. You're throwing with some speed. You're hitting like this. This angle is given. I think angle is given. No.
Angle is theta, but that's it.
Yeah, angle is theta. And this is inequality, right? It's not equality. So you have to just check out which one is bigger or smaller. So in the case 2, it is still going upward. So it will not reach the maximum height. So H2 is going to be least, right? And I can clearly see that the
1 and 3 will be the same.
will be same.
Yeah.
So
Problem was in the third question actually. First and second I could solve.
okay. Maximum height attained by ball A from the ground. And what is given to you?
Nothing except the time of flight given in the second
so we
question.
have done H max and T. We have relation.
Yes.
Time of flight is 2 UI by G.
Yeah.
And H max is UI square by 2G. And if you replace, you know the answer. GT by 2 whole square by 2G. So it is GT square by 8G. I mean 8. So yeah, so H is
Okay.
G by T square, right?
Okay.
We have done this, right?
Yeah.
You can also do this.
Understood.
Yeah, so this is not difficult. So that's why I say you have to write sometime the component form, because that will give you more sense.
Yes, sir.
So the vertical height and the time of flight both depends on the Y component.
Yeah.
Correct?
Yes,
So
sir.
X component will not matter. And because both depends on the similar component, so they will have relation always. Okay.
Yes, sir.
Any other question?
Sir, comprehension 2, could you give a hint on like how to do? I wasn't.
Because the planes are mutually perpendicular, so you have to take the component form. That's the best way.
Okay.
So you are throwing something like this, it is hitting at right angle, right?
Yeah.
So there are two things. First is in this direction, the displacement this much. And because you're hitting like this, so this component is 0 for velocity.
Yeah.
So you can choose both the relation to get the. So you know what is the displacement in this direction. You know what is the acceleration in this direction. So you can write this displacement equals to half G component in this direction, which is this one, whatever G dash into T square.
Okay.
And then you can add the Vx equals to 0. So this direction you can say Ux minus G dash double dash T equals to 0.
Okay.
So just play with the component idea, you get that.
Okay. Yes, sir.
So not difficult. Okay. Any other? And there's something very interesting. U and V are mutually perpendicular. So you cannot take write U dot V equals to 0.
Okay.
I mean, if you think in vector form,
Mhm.
because
Yeah.
you may express things in vector form.
Yeah.
So you can write U dot U plus GT in vector form. You can write like this, right?
Yes.
So this is U square plus U dot G into T equals to 0. And U and G, you can see U and G are at what angle? So you can find the angle. It's 60 plus 90, 150, right?
Yeah.
So it is UG cos 150 is how much?
Minus cos 30.
So you can find that.
Minus root 3 by 2.
Pardon?
Minus root 3 by 2.
Okay. So then you know this, you will cancel out. So you get U equals to root 3 by 2 into G into T. And U is given how much? 10 root 3.
Yeah.
So T is 2 seconds.
Oh, okay.
So fast you can do by vector also. There's always ways in which you can attempt question, and you have to think your brain. That's why I say kinematics will give you the way to think,
Yes.
and component and vector all are useful. So you have to always make the optimal choice, like which way I can go faster.
Got it.
Okay. Any other doubt?
No, sir, not at the moment.
No. So you can try. I mean, I hope you will get the answer. It's not difficult.
Yeah.
Anyone having any other doubt? ALP, you did? Just
Yes.
all questions, any doubt in that?
No, I was able to do. Two of them are still remaining. I was still doing.
You solved the question number 4?
Question number 4 and 5 are only remaining.
Question number 4 and 5 are the only question which is worth solving.
Ha. Because
So-
5 also, I was actually getting confused how two parallel straight lines they've drawn actually.
Question number 4 can be solved in 1000 ways. I'll show you few thousand. The rest you can attempt. So I'll show you the use of geometry, vector, and whatnot. So for any question based on the inclined plane, there is a very simple way of solving. Very simple way.
I tried doing it in the frame of the plane only.
Yeah, that is of course one of the way.
Yes.
So you're throwing with speed V0, okay, from height h, and it is hitting at what angle?
Perpendicular.
So
That's
you have lot of information given. So you know this component is 0. So you have to write the v equals 2 plus 80 in this direction and make it 0. That's it. And to get the initial velocity in that direction, draw a line parallel to that line, right? So if you draw a line parallel to the plane, you can find the component in the very beginning, right? And this angle is how much? 90 plus alpha. So this will be how much? 90 plus alpha. The
Yes.
corresponding angle, what do we call the interior allied angle, right?
Yeah.
So the sum is 180. And because this is 90, so this is alpha anyway. So not a big deal. So the idea is very simple. The V not cos alpha minus G sine alpha into T equals to 0. So I got the time of flight. That's very simple. V not cot alpha by G. The first part is done.
yes.
Okay. And then I have again few thousand ways of solving this question. And the few thousand ways is like, okay, I'll just first solve with the very basic which you understand, the displacement method. So if I draw a perpendicular, then this is the displacement in the direction normal to the plane. Correct?
Yes. We can
And this
use
is how
tan
much?
alpha.
It is h cos
sorry,
alpha.
cos alpha.
So to travel h cos alpha, what is your initial velocity in that direction? It is v naught sin alpha. So v naught sin alpha into t, which is downward, plus half g sin alpha into t square equals to h cos alpha.
G cos, no?
G cos. My bad. So now it is done, right? T, you can substitute t here. And you got the answer. This is one way of solving. What are the other ways of solving? So here I use simply the idea of velocity and displacement to get the answer. Method 2. Let me show you separately. And if you want to get rid of such kind of component and all this thing, there is a simple way of doing it. Very simple way. So you throw it like this. So I think I will take the most optimal way. This is easy, right? And this gives me t also. This is v not. So in time t, how much will travel horizontally? So your horizontal displacement is how much? V naught t,
Okay.
correct?
Yeah.
So this is simple way of solving. Because your velocity is horizontal, so in the time t, you will travel how much now? Half gt square. And you will travel v naught t. So how much is this much left? And this is, so you can simply write in triangle tan alpha equals to, and you're done. Understood?
So could you please explain this one again?
In this triangle, I tan theta, that's it. And we know that everything will fall down by half GT square in time t.
I know the thought process behind this method.
Okay, so if you are hitting a plane, then we can always use the alpha, because we know that how much you will travel in the same time horizontally and how much you will travel vertically. So we can always do the triangle. So this triangle is always there.
Okay.
No matter which question you are solving. And the best thing is, because I'm throwing horizontally, so I know that V naught will not contribute in the vertical motion, right?
Yes.
Because V naught is not going to contribute in the vertical motion. So I knew that things are going to be easy if I write like this, because I will only get the half GT square term for the vertical motion.
Call from CJ5.
Okay, sorry. So whenever we know the motion is horizontal, this is the best way to attack a problem.
Okay.
Okay.
Understood.
And velocity is perpendicular to the plane, so you know the angle also. This is V is this way, and you know that what will be the X component. You know what is the Y component, so you can also write the VY relation, X relation. I mean, there are many ways you can do the question. So what I did was I used the displacement values. So I know that, okay, this is V naught T horizontal and half GT square vertical. So rest I know, because the total length is H, right?
Yes.
So if you follow by half GT square, then what is left here? H minus half GT square.
Hmm.
And this doesn't require any component. Okay.
Yeah.
And also you can find the range also if you need. So because this is range on the plane. So this will become R cos alpha equals to V naught T.
Yeah.
And again, you can find T by the displacement method like this, the way we did here or here. So hitting something perpendicular always gives you one extra method to solve.
Advantage.
Okay.
Okay. Clear.
And if you just use the simple vector, this is V naught T vector in displacement, and this is half GT square. And now it is hitting the plane. So it's the same thing. I mean, if you do like this, you get the same answer. So path doesn't matter. The path is something which we draw, but if you think vectorally, then path doesn't matter, right?
Hmm.
So try the other one. I mean, it's not difficult. Shall we start the relative motion now?
Yes, sir.
Yes, sir.
So the question is why it is essential or maybe required to study the relative motion, because most of the question, in fact, almost all questions can be solved in the ground frame without any effort. I mean, of course, you have to write a lot, but that's okay. So is it really essential to study the relative motion? Can you solve every question from the ground frame? If I talk about the JEE
Yes, but
syllabus, then
it
yeah,
will
we
be
can.
difficult, right?
It is just a bit tedious, nothing else. So it is always
Yes.
easy. Now the question is, we have to understand one big concept that's called the so this is the key idea called the time invariance. And time invariance is the essential assumption of a Galilean physics, or you can say Newtonian physics. So when we talk about the Galilean physics or Newtonian physics, we have to assume that no matter which frame you choose to observe an event, the calculation of time will never change. Do you agree?
So for
Yes.
much less than speed of light.
That's why I say Newtonian physics. So if you go to the Einstein world, things will change. Okay. So in the Einstein world, the time of an event depends on frame. So the same event, okay, will happen at different moment of time. So you may be dead in one world, but you are still alive in the other world. Quite possible. Okay. So time invariance is the key idea, which we actually try to discover through the chapter of relative motion, that we have to look for a frame which can give the motion in a most simplistic form. And if I know the motion is happening in that frame, in that form, I can use that idea to find my time. Because no matter which frame I choose, how the motion may appear, the calculation obtained in one frame will be equally valid in every other frame. So why to go to the ground frame if I can get the answer in the some better frame? So for example, let's say talk about a simple question like we have an elevator, and the elevator is descending with some initial, some acceleration a naught, and then you throw a projectile. So you throw something. Then how will be the path of this projectile as the time will progress? In the ground frame, it is very complex. Because you have thrown something like this, but while the time it is hitting, the elevator has come down, right? So you threw the projectile something like this, but when it actually hit the, the floor, it actually hit like this. Now this is the actual path. If you attach a LED bulb to the projectile, and if it is a transparent elevator, the guy will see this path, right? When it is hitting. This is one event that you hit the floor. But how the motion will look like for the guy who is sitting inside the elevator? Correct? For this guy, the floor is not moving. And because the elevator is, kind of descending with acceleration a naught. So what is the acceleration of the projectile in the frame of elevator? So general tendency of the object is this will have the acceleration in the ground frame g downward. But the guy is also accelerating downward with a naught. So what he will exactly see as an acceleration? Will it see g or something else? So
G
what
minus A naught.
acceleration? Yeah. So what acceleration this guy will see? This guy will see g minus a naught. So you will say, okay, this is g effective, and you will solve the question the way you solve in the ground frame. But you will use this idea for calculation of time. If you try to find the displacement, let's say if you try to find the vertical displacement, then in the elevator frame, you'll get a different answer, and in the ground frame, you'll get a different answer. Because in the ground frame, your displacement in the y direction will be UIT minus half GT square. But for this guy, the displacement will be UIT, because let's say elevator was at rest in the very beginning, so there is no relative value. But he will write G effective T square. I mean, what he will see, he will write. So that's simple. That's okay. What you feel, you can write. You are free to write what you feel. So displacement in the ground frame, displacement in the elevator frame, of course, all are different. In fact, if I know what is the height, I know this is the displacement, correct? Isn't it? So we know that displacement of this, the vertical displacement of this projectile is H only for this guy who is inside the elevator. But for a person on the ground, definitely it is more than H, right? H plus something, isn't it? So, of course, you can solve every question in the ground frame. The idea was, can we find a frame in which things are simpler? Because time is invariant. And actually, we use the idea of a relative motion for most of the calculation of time, actually. For other calculation, we need to read the question that what they are asking. Are they asking the displacement in the relative frame or ground frame or something else? And what they ask, we have to answer it. Is this clear what I'm saying?
Yes.
Yes.
So time invariance is the key factor. There is nothing else. In a relative motion, we have to only understand the time. Now the question is how we can write the equation of two particles. So generally we talk about the relative motion for two objects, two particles. We don't describe the relative motion of three objects together. We can only say a relative of one with respect to other. So two will be involved at one time. So it is easy to write. Let's say this is a particle number 1 and this is a particle number 2. So particularly in case of projectile motion, the good thing is that both will have the same acceleration. So what will be the relative acceleration in projectile motion? So what is A relative? What is A12 or what is A21? What do you think? And this is the biggest, you can say, benefit using the relative frame, because I am looking for time. I know that acceleration is something which will bring down by equal amount for both the particles. So relatively, you're not moving vertically because of gravity. Gravity will never kind of contribute relatively. And therefore, we are getting rid of acceleration. So our equation will change from the quadratic to linear of time. Do you realize this?
Yes, sir.
So that is the first benefit which we always think of, that the relative will always make the quadratic term vanish. And when it will vanish, whenever there is a relative 0, whenever there is a equal acceleration, you can always think of a relative motion. If you know inherently that the acceleration of both are same, generally it is my tendency to use the relative motion. Okay. So if I start with a very basic, the definition. So this is the first particle. So this is called the position vector of the particle 1 with respect to ground. So what we call this line? We have done in vector. What we call this line? So it depends on the arrow. So if I put an arrow like this, what you can say? This is called R1. So this is called R2. So this is called this arrow represents what?
Position of 2 with respect to 1.
Yeah. So if you ask origin, where is 1? So the origin will point its finger like this. 1 is there. Where is 2? 2 is there. So this arrow is like the, you are pointing finger to a guy. So who will point this finger? This finger is pointed by which particle?
1.
1.
For whom? 2. So how we write? Position vector of 2 as said by 1. So we write R21, and we have done this. I mean, this is not a big deal. R12. So with the first subscript goes to the object. second goes to the observer. So it is always this order, R of object with observer. Do you realize this, what I'm saying? So a double subscript notation is meant for the relative motion. A single subscript is always for the ground plane. So that's simple. And from triangle, you can clearly see R21 is how much? So relative means you have to subtract. And who will subtract? Object or observer? What do you subtract? Object or observer? And in vector, what is the meaning of subtraction? A negative vector represents what?
Opposite orientation.
Direction.
Yeah, it is the reversal. Reversal of direction and addition. So there's nothing like a negative in vector. And that is logical. So if you differentiate, what you get? If you differentiate, you know this is V21. This is dr21 by dt. And this will exactly give you what? V2 minus V1, which is nothing but again the resultant of the object and reverse of observer. So what you have, you have. And observer will give its own value to you in the reverse direction. And whenever you add these two vectors, you will get the net value. And if you differentiate once again, what will you get? So this is the whole idea of relative. And how we write the typical canonical question, if we know that A to A relative, if A relative is constant, then we can always use the canonical question. So what is the equation? V equals to, how to change? V relative,
U relative.
U relative, A relative. And then if you want to write 1, 2 form, you can write 1, 2, 1, 2, 1, 2. And no need to worry what is 1, 2. You can just keep the sequence intact throughout. Or you can write V21. So whatever you choose, the sequence must remain uniform throughout. And then you can go one step further. 1 minus 2. 1 minus 2. 1 minus 2. And now if you want to write for the x direction, take the x component, write the same way. If you want to write in the y direction, write the same component, get the same answer. It is up to you. Okay. So what is really interesting? When they have the similar acceleration. So when you throw any projectile, it goes in a parabolic path. But when you throw simultaneously two projectiles, and if you make one of them as an observer, what will happen? If you make one of them as observer, what will happen? The gravitational effect will vanish.
Yeah, in its reference frame, it's just uniform motion without.
It is like for two, one will go which way? U1 minus U2 resultant. Do you realize what I'm drawing?
Yes.
So for two, the one will appear to be moving this way without any acceleration. And without any acceleration means what? With constant velocity. Path will be
straight line.
And what is the velocity of 2 in the frame of 2 itself?
0.
So it is at rest. So this is a fixed point in space, which means the observer should be treated as a fixed point in space. And other will move in a straight path. They may ask you find the minimum distance. Draw perpendicular. Okay, so we'll come to this in a more detail. Look at this. So imagine there are two particles, some random diagram. And this is particle one. So this is called R. Tell me guys, R.
1.
So this is called
R1.
is this part clear?
Yes.
Okay. Let's say one is this way. So I'm taking A relative 0. Let's say there is no access and we will deal with only velocity. So case one, when A relative is 0. So in such case, you are really lucky. It is a straight line motion and it's very easy to judge the answer. So let's say this is V1. Let's say this is V2. Okay, now it is up to you to make the one of them as observer. Which one you want to make? You can choose.
1.
So you want to make an observer.
Yes.
So one becomes the fixed point of space. One will have nothing. Because you cannot have anything in your frame itself, isn't it?
Yes.
So can you run with respect to yourself? Can
No.
you accelerate? Can you move? Can you do anything in your life? That is no. I mean, your observation is for other. Your motion is always with respect to other. You cannot have motion with respect to yourself. Do you realize this?
Yes.
The moment you make one as observer, one is like a fixed point of view. It's a now point. And then two is far away as of now. But now two will have how many velocity? Because one is observer, no? So two will have two velocity. One which God has gifted. Which is V2, right? And what else? It will also have the net velocity of any particle is sum of its own velocity and the reverse of the other, right?
Yes.
Do you realize this, the way I'm drawing? And the resultant of these two will have any direction which I don't know as of now. So let me take the resultant this way. I hope there is no option. I mean, there is no objection. Can we say this as V21, which is the resultant of these two vectors? Hello, hello, hello.
Yes, sir.
So let's take this
Yes,
angle as theta. I don't know what it is. So if I continue this path, I can do it, or I can extend the line. Let me shrink a bit this. I don't have a space actually. So let's say this is V21. And then you extend this line. So what is happening? One is a fixed point of space and two is traveling this way for that guy. And you may be asked, can you find the minimum distance between the two particles? How close they can come? So what will be the minimum separation? And how we can get it? So the minimum separation of a point and a line is
The perpendicular distance.
Perpendicular distance.
that's simple. So draw a perpendicular, you're done. This is the organic way of solving any new question. When you are coming across any new question in which they are asking the find the minimum separation, make one as observer, other as the moving object. Find the net direction, draw a perpendicular, you're done. And we know this length because we know this length is either R21 mod or R12 mod, doesn't matter, right? So in most of the cases, you will be knowing this answer. So theta is angle between which two vectors? Tell me. Theta is angle between which two vectors?
R12 or V21.
Correct. So can we say D minimum is nothing but mod of R12 sin theta?
Yes.
And sin theta comes in which product? Sin comes in cos, cross or dot?
Cross.
Because theta is not known, so we can create theta from here. So R12 cross V21 is how much? Modulus. Okay. And now you can see the answer. This is R12, correct? And now we have derived the formula of D minimum only in vector form. One, two, two, one. Is this clear?
Yes, sir.
Now, what will be the condition for collision when they will hit? For collision, what should be the condition? Can you guess?
D-min should be 0.
Exactly. The D minimum should be
0.
that's logical, which means
R12 cross.
V21 and R12 are parallel.
Yes.
Do you realize this? Maybe.
Yes, sir.
Which means V21 will go this way only. Then only it can hit, na? That's logical. If one is at rest and other is coming to hit you, then other must be moving towards you directly in your frame. Isn't it? Hello, hello, hello.
Yes, sir.
And because this is the condition, when two vectors are parallel, then which property will make them equal? Two parallel vectors will have one property that we can equate. What we can
They're
equate?
unit vectors.
Very good. So we can write R12 upon its modulus must equals to V21 upon its modulus. And therefore R1 minus R2 upon mod of 1 minus 2 is V2 minus V1. So this question from the IIE Rodov. Have you seen the question? I think question number 7 or 8.
Yes, sir.
And this was asked in one examination. And that examination was NEET. NEET. NEET has asked question from Rodov directly. So they asked that what is the condition for collision of two particles? Having a radius vector R12 and velocity vector V2. Is this clear, guys?
Yes.
The second question is, after what time they will be at minimum separation? After what time they will be at minimum separation? Or how much time it will take to go from the initial position to the foot of the perpendicular? From the triangle you can say, na?
Yeah, using cos theta. Just a second.
And in fact, you can derive the answer for time in vector form.
R1 to cos theta by V21.
Correct. And then you can replace cos theta in terms of dot product.
Yeah.
So what is the answer? Tell me. So what is the answer?
Sir, R12 dot V21 divided by V21 whole square, mod V21 square.
Yeah.
Yes,
very good.
not the same.
Yeah. So if I say this is B, this is A. So we can add time taken to go from B to A equals to R12 dot V21. I'll take mod because time cannot be negative, so I have to be careful. And dimensionally, I can remember easily because I need distance upon speed. So numerator we have speed, so I will make it a square, right? So in case if you fail to remember the formula, you can think dimensionally, you get the right answer. And in case of D minimum, because I need only dimension of distance, so V21 will come here and will come here as kind of memory trick. Nothing else. Is this clear, guys? Tell me yes or no.
Yes, sir.
No, I will never say to remember these formulas, but the way we arrive at the formula, if you understand that process, you can solve any challenging question of a relative motion of, this is called the question of closest approach, or yeah, so you can say this is collision problem or closest approach problem. I'll give you a demonstration, don't worry. So theory is clear to all of you?
Yes, sir.
So you all have solved this question from the famous Irodov. And luckily we have two mutually perpendicular lines. So these are crossroads at right angle. And at t equals to 0, we have the first particle here at coordinate minus L1 comma 0. And it is moving with velocity v1, constant velocity. The other particle is here with coordinate minus 0 comma minus L2 and moving upward with velocity v2 constant. Question is, what will be the minimum separation between the particles? Find D minimum. Okay, what will be the condition for collision? You can directly tell. They must arrive at the corner at the same time because that is the only point they can meet. So condition for collision is a what? I think very simple. What should I write here? Tell me.
L1 by V1 is equal to L2 by V2.
Exactly. So they must reach the point of intersection at the same time, because otherwise they will never collide. Now, if this condition is not true, then they will never meet, but they will always move in a way that at some instant their separation will be minimum and then it will grow further. Isn't it? So question is, what is the minimum possible separation? You can use the vector formula directly to get the answer, or you can use the organic way of solving by making one of them as observer, other as moving particle, then do something, and we'll get the answer. So you can try for 2 or 3 minutes, then I'll solve. Question is, find the D minimum and T for D minimum. Question is clear to all of you? You're done? So what is the D minimum?
Yes, sir.
How much is D minimum? Tell me.
Sir, mod of V1 L2 minus V2 L1 by V1 square plus V2 square.
Is it under root or it's outside?
Under root, sir.
So I think that is correct, because if you make D minimum 0, you will get the same answer.
Yes, sir.
And how much time it will take?
That I have to calculate, sir.
Do it. Yes, Josh, there's what happened? You all got the answer, D minimum?
Not yet. Sir.
Why? You have a formula, you have to apply the formula, just write things in vector form and get the answer.
Sir, just applying Pythagoras theorem is fine.
Yeah, it's fine.
Okay, sir. Sir, but I'm getting like a pretty large answer.
No, it will be pretty simple answer.
Okay, sir.
Something like this.
Okay, sir. I'll try to simplify it, sir.
So which method, what you are applying here? Which concept?
Excuse me, sir.
Yes.
My answer, I'm just getting minus L1 V1 in place of plus L1 V1.
Which option? For time
For
or
time,
for?
time.
No, it is plus only.
Okay, I'll check it.
Sir, I used like similar triangles.
Yeah, that's fine.
Okay.
So that will be lengthy. If you are using a triangle, I think that will be very, very long.
Sir, no, sir. I mean, it's like super short.
Okay. Okay, send it to me. Just send me, I'll check.
Okay, sir.
Okay, look at the answer. Okay. So one is formula diagonal. What is the D minimum formula? R12 cross V21 modulus. So R12 means R1 minus R2 cross V2 minus V1. V2 minus V1. That's simple. Input modulus here. What is R1? The initial coordinate is how much? Minus L1 I cap plus L2 J cap cross V2 is V2 J cap V1 I cap V2 J cap, and we know how to take the cross, so I cross J will be left, so IJ is minus, so L1 V2 K cap, and then it is L2 V1 K cap upon under root of, and we have to take modulus, so this is so was this difficult? Maybe. I don't know. So it is about whether you know how to write vector or not. That's it. And the time is how much? It is the dot product. So just keep the same answer, make it dot in the numerator. What will you get? I will go with I, so L1 V1, and J goes with J, L2 V2, right?
Yes.
And it is the square of the V21, which is, that's the answer. Okay. Tell me, Parv, Darsh, Jash, what happened? So why you were not able to solve the question? For what reason? Explain.
So it just took some time. I was done with the velocity now. I was just doing the.
Pardon?
Right now I was done with the velocity. I was just doing the time thing.
Okay, you don't know how to write velocity in vector form, huh?
No, it's not that. I was able to do the velocity one. I was doing the time one right now. I'll just get it.
Jash.
I did the same thing, but I was having, I was getting plus over there, so I think I did a mistake in cross product.
The dot cross you all have forgotten, right? Very
No,
good.
dot cross, remember, I think I did a silly mistake.
Silly mistake. Parv will explain what is silly mistake. Okay. So can we do this organically without using formula? Can we?
I did without formula.
Very good. So to use without formula, we have to make one of them as observer or a fixed point.
Yes.
So which one? You want to make a fixed point or observer?
True, sir.
2. Let's say 2 is the observer. If 2 is observer, then 2 is fixed point. Then how one will move? Or how many velocity one will have? So one will have 2 velocity, its own velocity, which is V1. And what else? It will have V2 in which direction?
Downwards, sir.
And these are mutually perpendicular, value wise, you can see vector wise. So the resultant of the two will be somewhere in between. Okay, so I'll just keep it somewhere like this. You can draw either like this line or you can draw like this line. So to make it simple, I will draw like this in general. And I'll call this as V21. And from the vector arrow, you can clearly see V21 modulus is how much? What is the V21 value? Because they are mutually perpendicular, and we can also find the angle, right? So we can say tan theta is how much? How much? What is tan theta? Hello, hello, hello. Tan theta is how much?
L2 by L1.
Theta is the resultant of the 1 and 2, right? Velocity of 1 and 2, right? So V21 is representing the resultant vector of the two arrow which I have drawn there. So theta is representing the resultant. So we can always write tan theta equals to V2 by 1. Do you realize this? Yes or no?
Yes.
And because we don't know how much is this value, so you can choose any value, you can name it. So what you want to assume? Let's take this as some value. Y. So this will be how much? L2 minus Y. So what is the minimum distance between the point 2 and the line of motion? So draw a perpendicular. This is the D minimum. So how much is D minimum? So for that you have to find the angle first. So I think this angle is theta. I think so. Do you realize this is theta also? Hello, hello, hello.
Yes.
Yes, sir.
Yes.
So what
sir.
is the D minimum? D minimum is how much? And because we know tan theta, we can substitute to cos theta. What is Y? So we also know that tan theta is V2 by 1, but in triangle it is Y by L1, right?
Yes.
So Y is how much? L2 minus L1 V2 upon upon V1. And cos theta is base upon hypotenuse. I'll put a mod because this could be on the other side also. So this is how you solve organically. Okay. And if you want to find the time, then it is kind of cumbersome here. But what you did, I think Hasika did something simple. Just
Sir, I like joined 1 and 2. That is L1 square plus L2 square.
if you join 1 and 2, then that's fine. But what is the speed then in that case? So velocity in this direction is how much?
So for time, I'm telling sir.
Yeah, for time, how will you get that answer?
Sir, then like 1, 2, and then the point where like the D minimum like intersects the blue color line. That triangle is like a right angle. So it would be like mod of under root V1 square plus V2 square into T whole square plus D-Mains square is equal to L1 square plus L2 square.
Correct. Very good. Excellent. It's a really something new. So yeah, if it is coming here after time t, then V21 into t whole square. So you're using the D minimum answer here, right?
Yes.
But that is really cumbersome, I think. What you're doing is, yeah, maybe it's easy because maybe getting cancelled, right? So
Yes,
V21,
it's cancelled.
yeah. So V21 t whole square is L1 square plus L2 square minus D minimum whole square, which is L2 V1 L1 V2 whole square upon V1 square plus V2 square. So this is something, okay, this is I'm seeing for the first one. Okay, so I'm gonna solve this way also, it's really good. So L1, so L1 square, V1 square, L1 square, V2 square, there are so many terms, then L2 square, V1 square, plus L2 square, V2 square, minus L2 square, V1 square, L1 square, V1 square, oh my god, so much. And then minus 2 L1, L2, V1, V2, all upon this, correct? So L1, V1, no, L2, V1 will cancel out. So L1 square, V2 square, and L2, V1 will cancel, right? And then what we are left with is L1, V1 minus L2, V2 whole square, right? So this is what you did, correct?
Yes, sir.
Anyway, so that's a really cool way of thinking, and you got the answer in the right way. But that will require the D minimum calculation. That's why it's you need to know the D minimum answer first. Let's say if you are only supposed to find the T, then you have to anyway find the D, then solve. That's a cumbersome, so you can do that way. Okay, so there is a third way. For time, we have a really interesting method which I have taught in the chapter of mathematical tools, and that is using the calculus, right?
Yes, sir.
So calculus simply says that you start from here. This was L1 and this was L2 and this was T equals to 0, you're here. So after some time T, you will move slightly ahead, let's say. How much? V1 to, and this will move slightly ahead, let's say V2T. So what is the distance left, or what is the new separation between the particle as a T function? So this is L1 minus V1T, and this is L2 minus. So the distance is Z square equals to and you want to minimize the Z, right? And obviously the Z is function of time T. And if Z is minimum, then the square is also minimum. So dz square by dt will be twice of L1 minus V1T into minus V1 plus twice of L2 minus V2T into minus of V2 equals to 0. And you know how to get the answer from here on. So it's minus L1 V1 plus V1 square T plus L2 minus L2 V2 plus V2 square T equals to 0. You can see T is how much? So you can also find the time dependent relation first and then. So sometimes this is also useful. Why it is useful? Sometimes the vector may be difficult to write for you guys if you have to write the component. It was the right angle triangle all the time, so it was easy for you. If the triangle I change in a new shape, so perhaps you won't be so much comfortable. Okay. So there are two particles. One is here and two is here. So one moves with velocity V1 and 2 is starting from here, moving with V2. This angle is, let's say, alpha. This length is L. And you are supposed to find the minimum separation between the two particles. So what will be the minimum separation? Is it the initial is minimum, or we have to find the minimum after some time? So after some time, it will travel slightly ahead. So it will be V1T away from the corner, and this will be V2T from here. So what is the new separation? As you can see, right? So the entire length from here to here is how much? L plus V2T. And this entire length is V1T itself, because there is no initial value. And this is Z. So I think we can use the cos relation easily, right? Cos alpha is, I hope you remember the answer, right? A square plus minus C square by. And then you can rearrange the Z. And then to minimize Z, we can differentiate and we can get the answer. Is this clear? So the time calculation is sometimes easier in terms of calculus. And if you want to write in vector form, then you have to make x-axis properly and then choose y-axis and express the answer in terms of, okay. You can take y the way it is generally. Then you have to express everything in vector form with ij properly. And then take the same thing. So it is very easy. R1 is 0. Null vector R2 is Li. And the V1 is, we have to write in proper. So V1 cos alpha I cap minus V1 sin alpha J cap. V2 is very simple now. V2 I cap. And we know the formula for D minimum and T minimum, T, right? So we have a formula. R12 cross and T is. So it is not difficult, but you should know what to do to get the answer. So idea can be used anywhere. Or the third method, which we can do organically. So this is 2, this is 1. You can make one of them as, or I mean, I think the best is to make 2 as observer, or whatever you choose. Tell me what you want to make the observer, 1 or 2. Tell me, guys, what you want to make observer, 1 or 2?
1, sir.
If 1 is observer, then 2 will have 2 velocity, 1 like this. V2, and how the V1 will be?
Upward at an angle.
Alpha only.
Yes, sir.
You just write the values,
Vector addition.
and then it will have the resultant velocity. So we can in fact resolve V2 sin alpha, and this is
No, we can resolve V1 now.
V1. Let's see, I have it in V2. Okay, no problem. Just write V1. And this is V1. So in a better way, you can write like this. This is L. So it will have 2 component. V2 minus V1 cos alpha towards right. Or you can take left also, it doesn't matter. I mean, depending on which one you want to make assume bigger. And because we are writing the two mutually perpendicular components, so it is easy to find the resultant, something like this, which can extend like this. And this you can take as theta and draw a perpendicular. This is D minimum between 1 and 2. Correct? No. Yeah, this is moving this way. No? This is V21. This is V21. Correct? And because this is the resultant direction, so the minimum separation is this much only. But for that, it has to move this way. If it is going away, then it's not possible. So I think I have to switch the V2, right? This side. Only it is approaching, it will have the minimum separation. If it is moving, then there is no minimum separation. So I think I should have written V1. Okay, let me do once again. So if it is going the right direction, then the minimum will be L itself. But if it is coming towards left, then it will have the minimum less than that value. Just a minute. Oh, this is not required. So 1 is observer, 2 is here. So to have the minimum separation less than the initial value, it must have the velocity something like this, V1 cos alpha minus V2 and then upward. V1 sin alpha, and then the resultant is something like this. And then the minimum separation is this way. And this angle we can write at theta. So tan theta is D minimum by, no, not L, it is how much? It is tan theta is V1 sin alpha upon. So sin theta is how much from this tan? What do you connect? Numerator and upon cos alpha, which is equal to D minimum by L. So it is L V1 sin alpha upon this answer. Is this clear, guys?
Yes, sir.
And it is necessary. I mean, if it is not happening, the minimum separation will be L itself, because if it's going towards right, then it will never decrease. It is going to be always more. Is this clear? So do you realize this
Yes.
entire geometry?
Yes, sir.
All right. So we'll see some more interesting question. Particularly the question of collision of projectiles. You know, let's see. Collision of projectiles. So let's say we have two particles, 1 and 2. And one of the particles is thrown horizontally with some velocity V1, and 2 is thrown at some angle randomly with speed V2. The only information given to us is that they collide. So this is the actual path, usual path of each in ground frame. And it is said that, okay, they eventually collide. So question is, after what time they will collide? And because they're asking time, so we know that time is independent of frame of reference. So it is up to you to choose any frame and solve it. Nothing is given. If you need that something should be given, assume it and it will get cancelled out. Questions clear? The 2 is ground, okay? So just in case. So think for at least 2 minutes, then I'll solve.
So do we have the angle of projection for 2?
And that's why I said, if you think that something you need, assume it.
Okay.
Done.
Okay. So what's the time after which it will light?
H upon under root of V2 square minus V1 square.
Okay. So explain how you solve this question to everyone.
What we can do is one thing we know is
No,
that
no.
V1.
No, what you did tell to the everyone, okay? Not what I can do. I can do a lot of things, not worry.
What I did was I resolved V2 in, let's take an angle theta at which V2 was thrown.
So from here or from here, where you have taken?
From the x-axis.
Okay, fine.
So we can write one equation is that V1 is equal to V2 cos theta.
V1 equals to V2 cos theta, right?
And we can now use relative
why we writing
motion.
this question? Why we writing this question?
Because both of them has to travel the same displacement, distance range, right? In the same time period.
Correct. Very good. Yes.
And one thing we can now use from relative motion is, since we know that the first particle does not have any initial velocity in the y direction, whereas the second particle has V2 sine theta upwards. But
Correct.
since both of them are in the same frame, we can just write time as h upon V2 sine theta.
Correct.
And now we can use this cos theta to find that sine theta.
Very good. That's the right answer. Right approach also. Anybody else tried some different ways?
No, sir, same approach.
There's
So similar way, I tried resolving and
pardon?
So
yeah, so
Yes.
the same approach, resolving and going about it.
So you got the answer?
So I'm still doing it.
Hmm?
I'm doing it.
So you're doing some research. Yeah, Hasika, you were saying something.
sir, I tried by considering a frame which is moving downwards with gravity, I mean acceleration due to gravity.
Correct, correct. The G frame idea. I'm supposed to, I'm about to discuss. So,
Sir, yes.
I used the same thing actually, because
mhm.
since both of them are in the G frame, we
Correct.
can neglect it.
Correct, correct, correct. Very good. And you can see, interestingly, they haven't given the angle. And if nothing is given, something is not given, it is always as per the laws of physics, it is not required. So it means you can assume and eventually it will get cancelled out or it will get replaced by something. So that is always there. So there are many interesting ways you can solve. Of course, you can solve in the ground frame without knowing the relative motion. And the idea is simple. They all travel equal horizontal displacement. So the x is same for both. So x1 equals to x2. It's like ground frame or something. So you can say v1t equals to. You have assumed some angle v2 cos theta into t. This is what E got, right? Just the way you got. And then in the vertical direction, you can write the first will travel how much? Half gt square in the downward direction. And second will go up by how much? v2t minus half gt square, right? v2 sin theta t minus half gt square. And the sum of the displacement must be h. And therefore you get the answer that, okay, anyway, t equals to h by. So this is something, even if you don't know what is a relative motion, you could have solved the question like this by common sense. Okay, this is what I'm supposed to do. And write the things in two different directions which are mutually perpendicular and get the answer. But we have even a better way of thinking. Okay. Because we are learning the relative motion, so we can develop some more ideas. So let's try to solve as per the idea of the relative motion. So we know that 1 is thrown like this, 2 is thrown like this, and if nothing is given, we can take some angle. Okay, I'll take this angle as theta. Now you have to choose one of them as observer, right? So which one will choose? 1 or 2? 2. If 2 is observer, then 1 will have 2 velocity, its own and opposite of 2, isn't it?
Yeah.
So in the frame of 2, how you will draw the ABD? I mean, the velocities. So 2 is at rest. And 1 will have how much velocity? V1 towards the right. And it will have V2 like this, value wise, and angle theta. Is this clear to all of you guys? Tell me yes or no.
Yeah.
Yeah.
And 2 is not moving. And you want to hit the 2, right? Because you want to collide. It means the 1 must hit the 2 in the frame of 2. The 2 will see that 1 is approaching 2 itself. And when this will happen? When the resultant velocity of the 2 vector must be. We have done this, right? So the resultant of the 2 vector must be like this. So V1, 2 must be like this. Yes or no? Hello, hello, hello. Tell me.
Yes.
So the two will see that one is approaching this way, which means if I resolve the velocity of two, one along the expected line, another perpendicular, this is v2 cos theta, and this is v2 sin theta. To move this way, which component must cancel out each other? If one is traveling this way in the frame of two,
Horizontal.
the horizontal, the component perpendicular to the line joining the particle must cancel each other. That's the thumb rule of collision. If you know that something is moving in that direction, then the net component perpendicular to the line of motion must be zero. Is this clear?
Yes, sir.
Yes.
So that's simple. So v1 must be equal to v2 sin theta, which we have got from here itself. And the idea was that because 2 will never see any acceleration, so it will only travel with v2 cos theta. Correct? So how much time it will take to travel h? Distance upon speed. And we are done. Is this clear?
Yes, sir.
So the collision means the resultant velocity of any particle must be towards the other particle. Always. And because they will not never see the acceleration, so we can just write the speed, time, distance relation, which you know already.
So,
Yes.
sir, can we solve this using displacement vector diagram?
Yeah, we are going to solve that way.
Okay.
So that's the next method you can see. Now, when we are solving question of projectiles, where both the projectile will be free falling under gravity, I will bring the third observer and I will name it G frame observer. And I'll assume that that guy will also jump simultaneously with the other two objects with the same acceleration G. So if you also jump and you are the observer, again, you will not see what you will not see. You will not see any acceleration for any of the objects, right? You are a guy which is also free falling. So for you, every other particle will be non-accelerating
Yes.
if they are
Yes.
under gravity. So G frame is a good frame if you want to solve motion of two projectiles. And therefore, if I draw the diagram, in G frame, every particle will travel in its own path with a constant speed forever. And they will collide when they meet at this point. So the first will travel v1t and second will travel. And this is a right angle triangle, connect the v2 square t square equals to. So now I know why the answer is this. And it is really interesting. In G frame, I'm not supposed to turn anywhere. Just continue the path and join the path. And get the time the way you want. You'll get the right answer. Is this clear what I'm saying?
Yes.
Yes, sir.
Yes, sir.
So there are many applications. I mean, I'll just give you one of the questions. So let's say we have two towers, H1, H2, height, D is the separation. And there are two projectiles. Both are thrown simultaneously. One is thrown this way, other thrown this way. And they collide. They collide. Eventually they collide. So if they collide, then what is the relationship between H1, H2, D, U1, U2, theta? Theta 1, theta 2. To find a relationship between U1, U2, theta 1, theta 2, H1, H2, D. Again, there are many ways of thinking. See in how many ways you can think.
Done.
Okay. So what is the relation?
So we got two equations we can get. First equation we can write as v1 cos theta 1 plus v2 cos theta 2 into t. I'm assuming that let the time before colliding be t
Yeah,
equal to d.
very good.
And one more equation we'll get is v2 sin theta 2 minus v1 sin theta 1 into t must be equal to h2 minus h1.
Which one is bigger?
u2 I'm assuming.
Hmm.
Hello.
Okay, I think you can see clearly the
u1 is bigger actually.
one is below, so it has to move faster to catch up.
Ha.
So okay, it is U1 sin
Sin
theta
theta
1
1
minus U2
2
sin.
sin theta 2 into t must be equal to h2 minus h1.
Correct.
Now we can take t from any of the equation and substitute in another.
Correct.
So we'll get the relation.
So your answer was 2 minus 1, right?
Yes, I did a mistake.
But anyway, that is okay because here, but you have to understand from diagram here.
Understood.
Okay, okay. Anybody else getting the answer? That's perfect. Tell me.
2 minutes.
So I'm trying with the G frame.
See, you have to think in 3 ways. First, you all have to think in component form first. Once you're done with the component form, then think of G frame, then think of a relative motion.
Okay.
And in the very beginning, just think of the, you know, vector form also of kinematics. There are many ways in which you can solve this question. Simply write the vector form of kinematics. What is the meaning of meeting? You have similar coordinate, right? So how we write the formula for the displacement? Delta r equals to ut plus half at square, right?
Yes.
So we can write as delta r as r minus r naught equals to ut plus half gt square. Or let me keep it a only. And then I put a relative, r relative. And a, what is a relative here? So luckily in this case, a, this term is 0 now. And when you meet, see, this is the general formula. But at the time of meeting, what will be the r relative? This term will be also 0, no?
0.
At time of collision, r relative is always 0. And so we have a very simple answer, minus r naught relative is u relative into t, that's it. And now we have to substitute in vector form, that's it. How to write it? So for that we need to choose some coordinate system. So I can call this as x, this is origin, I can take this as I can take y. So what should I write here? If I want to write the kinematics only, not any idea of, you know, any method, just kinematics, pure kinematics. So you may write minus and r naught relative is 1 minus 2 or 2 minus 1. So what is 1 minus 2? So 1 is where? H1 j cap and 0 I cap. What is 2? D I cap and H2 j cap. This is so simple. What is U1 vector? U1 cos theta 1 I cap, U1 sin theta 1 j cap minus, and U2 is U2 cos theta 2 I cap plus U2 sin theta 2 j cap all into t, and you just compare the I coefficient and j coefficient on both sides, you'll get two relations. That's it. It will give you every answer. So first is kinematics. You just write the kinematics in relative form and get the answer. If you're not comfortable with this way of writing, write kinematics for each direction separately. Write kinematics for x separately, write kinematics for y separately in a relative form and get the answer. Which means I could have written minus x naught relative is ux relative into t, and then yeah, minus y naught relative is. So you can always convert things like this and then write the answer. So this is called the mechanical way of solving. I mean, you don't understand much, but you can still, if you follow the process, you get the answer. But if you understand a lot of, I mean, relative motion, if you understand the idea, you can do by 1000 meters. In horizontal, we can see it is only velocity which can bring you closer. So one is going right, or two is going left, so they must travel equal to d. That's it. So u1 cos theta 1 into t plus u2 cos theta into t must be equal to d. So equation 1 is also you can do mentally. And for vertical, I can see the 1 is below, 2 is higher. Both are going upward, so one has to travel more. So to travel equal y displacement, you can say h1 plus u1 sin theta 1 into t must equals to h2 plus, because half dt square is same for both. I mean, there are many ways of thinking, isn't it? Just think component wise, what will happen? So to meet, we have to do this way, right?
So
And then, yes.
I was trying using the G frame thing, but I
So
didn't get it.
you can always get with G frame, that's very easy. So in the G frame, you can do like this.
Sir,
Yes.
I'm getting u2 by sine theta 1 minus tan inverse h2 minus h1 by d is equal to u1 upon sine theta 2 plus tan inverse h2 minus h1 by d.
What is sine inverse? Why inverse is coming?
Tan inverse, it's inside
Why
the sine.
tan? Why inverse will come at all? For what reason?
So I'm applying the sine rule, like I made the triangle and
So
because
one
there
will
was
go
an
like this, two
extra
will go like this. That's
angle.
it.
There was an extra angle that I had to add subtract.
No, there is no angle. So this is theta 1. So in time t it will travel, u1 t will travel. And we are done. Isn't it? So from the left side, you can see if you add h1 plus u1 t sine theta 1, it will give you the length AB,
Yes, sir.
which you can also write as h2 plus u2 t sine theta 2.
Yes.
Same answer.
So get T. Okay.
And u1 t cos theta 1 plus u2 t cos theta 2 will always give you d.
Yes, sir.
So in the G frame, they will move in the path, in their respective path will meet at the point of intersection of the lines, and we know how to write it. Why inverse is coming? I don't know.
Sir, I joined them both the points directly, both the points of projection. And then I applied
Why
sine
join?
rule in the resulting triangle.
Yes, sir. Same.
So I think there's no need to join because you are supposed to find the time only. By joining, what you achieve? Tell me.
Sir, we need a relation, right?
So we can replace the t, no? I'll get the relation. I want relation of all the values given, right? Not the t, right?
Yes.
So t I can get two ways, right?
Yeah.
T I can either get in terms of h1, h2, or I can get in terms of d.
Yeah.
So it's a redundant information given, right?
Yes.
So I can replace t. The t will be same from both the equation, isn't it? The t
Yes.
is going to be same. Yes or no?
Yes, sir.
So that's it. You have to always think kinematics in a relative form is something like just write the things in x and y separate. And in many situations, you will find that the component is easier. Many situations you find that the vector is easier, G frame is easier. You have to figure it out that which method is, most optimal way to solve question. That should click, and also you practice a lot question, then it will click. Is this clear?
Yes.
So there is a question, I think, in JEE Advanced. Let me see it. I have shared a relative notion. Yeah. So the question number. Yeah. Go to page number 18. Page number 18. Are you there?
Yes.
Solve question number 1 and 2. Part 1. So for every meeting problem, the R final is 0. The A initial may or may not be 0. The A relative may or may not be 0, which we don't know. The R not relative will have some value which we don't know. So this is the way of writing. So delta R is displacement, which is the difference of position. So if they have the initial difference You have to think that way.
So the comprehension problems, right?
The first and two, yeah, it's not just exercise 3, part 1.
Sir,
Yes.
which question number?
1 and 2.
Okay.
Page
Acha,
number, page number 18.
okay, okay.
Sheet का 18,
JEE
but
2000,
19 on the
JEE
PDF.
2002.
The
Yeah,
18 of, not of the PDF.
yeah,
On the
PDF.
PDF set.
Yeah,
page number
PDF,
18.
PDF. The PDF which I have shared.
Question
So
number
solve 1 and 2, 1 and 2. The first two problem.
2000.
2000, 2002. So I'll give you 6 minutes to solve one question. So in total 12 minutes. Done.
Just a sec.
Okay, I got all the canonical question. Which one starting component form Vx equals to U plus AXT. I think I have written somewhere, right? Maybe. And how to add the displacement? Why and why not the coordinates, right? So choose the proper coordinate system, write the answer, get the answer. It is so simple. And if you want to write in vector form, you know how to write. And if you want to add in the relative form, just put a relative everywhere. And every term will be replaced by the difference of the two terms. If you remember this much, I think you can solve any question. Anything beyond this is bonus. If you can think more. Done, guys. First part is done, Josh.
Yes, sir.
First part is done. Question 1, you got the answer? Tell me yes or no. For 1, you got the answer?
Just a second, checking the answer. Oh my God, 1 second. Correct.
Send me the solution.
Just a second, I didn't wrong. But sir, I couldn't use relative motion, so I'm now trying using relative motion.
No, send me first. You send me what you did.
Okay.
It will collide only once, but we are solving the quadratic for the time, which means how many times it will travel that height. It is not about collision, it is about height, right?
Yes, but we also need to see the x coordinate also, right?
Yeah. So when you are coming down and hitting it,
So
means
I
it is
got
second time.
3 equations, and then solving those 3 equations will get time. But now I'm trying to using relative motion.
Where you have solved the question. I need so complete solution from end to end.
Okay,
Where
right.
is the answer? Where is the solution? You only send me 3 questions. Where is the answer? How you got the answer? by looking at the three questions, by solving the three questions. Yeah, Tanish. So in your case, it is hitting at the downward journey, so it is traveling for the second time. Because in any projectile, when you come down, when you have already crossed that height, so you will hit down when it is second time, isn't it?
Yeah.
So D should not be 0, no?
Okay. I thought corresponding to that range, because at first instance, when that height is attained, the collision won't occur, na?
No, that is not your concern. Your concern is you are solving a quadratic in height.
Hmm.
So for a given height, we have always 2 times.
Huh.
And because you're hitting at the downward journey, so the first will not be the answer. It must be second answer.
Understood.
Yeah, that's for what's your thought process so far?
Sir, I'm getting the answer, but it's not matching.
No, what you're doing? Are you approaching the right way? Using the concept which is being taught?
Yes, sir, I
Using the
think so.
information which is given here. So what are the information given here?
Okay, so sir, we know the initial separation between that plank and stone. In x coordinate it is 3 and in y it is 1.25.
Yeah, so
So-
it is logical to solve in x and y separately.
Yes, and one more information is given that when the stone hits that plank, the angle with respect to horizontal is 45, but during its
Yeah.
downward motion. So
Yeah, so you know that how to relate Vx Vy.
yes, sir. So Vx plus Vy should be 0
Vx plus Vy should be
because Vy by Vx should be -1, right?
correct. So that's 0. Yes, right.
So
Then substitute the formula. I mean, Vx and Vy formula, you know how to write.
yes, sir, I did. Like Vx was pretty easy. I wrote it as u cos theta minus.
You simply write Ux. That's it.
Okay. So Ux minus 1.5t should be 3.
1.5t.
Because that plank is accelerating with 1.5 in positive x direction. No?
Okay, so
That should be equal to 3, I guess, because it should overcome that part in time t.
once again, tell me once again.
Ux
Hmm?
Ux minus 1.5t should be 3.
No, whatever is the equation you wrote.
No, sir, I'm telling about that only. This in x direction.
So in x direction, what you're writing? Displacement, velocity, what you're writing?
Sorry, Ux state should be displacement.
So what you're writing? Then
Ux into t minus 1.5 into t should be 3.
Okay, correct.
And then in y, the plank does not move in y direction. So first I found out u sine theta from the equation u sine theta t minus 5t square is 1.25. And then we need to find Vy, not Uy. So Vy should be u sine theta minus 10t. So then I substituted the u sine theta from the above equation.
Okay.
So I
But
got
this is
Vy.
not you can simply write Ux Ey and also express Vx Vy in terms of Ux Ey and you will get the answer much easier. Because theta is not given and theta we cannot figure it out. So it's good to use the component symbol only.
Okay, sir.
And try to replace the unknown, which is Ux Ey. You get 2 equations to substitute.
Sir, actually I got a quadratic in t, but first I got that was imaginary roots. Now it's something irrational.
Okay. Try again.
Okay.
Okay, that's what is your thought process? What is going on in your mind?
Sir, I did the second one first. I've completed that. And now I'm on to the first one.
Second, you got the answer?
Yeah.
Okay. Send me the solution, what you did.
Okay, sir, I've not written much. It's like most of it was obvious. So I just written.
Okay, write whatever was obvious to you. Just write in word that this was obvious to me.
Sir, okay, one second. One answer is matching, but I haven't used one information that was given, so I'm not sure. I'll check again because I didn't need to use one information that was given, but the value was matching. So I might have done some wrong method, but got the right answer.
What is the height of the plank? Just what is the height of plank?
1.25 initially.
It is always that much only.
That's all.
That's why we are using, right?
And what is the
And
x?
but
x
x coordinate will keep on moving, right?
Yeah. So what is the x coordinate you're writing?
So 3 plus 3 by 4 t square
So
Equals
this is
to.
also my method.
uxt.
So what you have written?
So that's
Check.
what I've written, right?
Check.
No, I've written the same thing.
3 plus 3t square by 4 equals to what you have written? UIT plus GT square.
I substituted ux over there. Arey, wait, I didn't send you the complete photo. Wait. I know what I did. See, now check. That is minus UIT. Actually, the photo got cropped. Hello. So basically, what I did was we got 3 equations and
Correct.
3 tables. I'm trying to find a faster way, but I can't actually. Because solving
Okay,
3
I think
equations is bit.
again, we have done the same mistake. What you are writing? Are you writing displacement or velocity?
Displacement.
What is the formula for displacement?
Normal, it is ut plus gt square.
So what you written there in the first equation? Check.
Array, that t. Got it, sir. Actually, got it.
Silly mistake, huh?
Yes, sir. Blunt.
Second.
Actually, I was not getting the answer due to that t only. T was missing.
See, you're only supposed to, Tanish, you're only supposed to write the displacement same position to get the answer. You are meeting at a point, so you have to just equate the point. So how much you will travel to reach that point? Just think about that, you will get the answer.
I think that's what I was doing. Else again.
That's how you got sin theta minus cos theta equals to root 3 minus 1.
Me?
No, does.
Sir, I subtracted both the above equations. So, and then like root 3 by 2 minus 1 by 2 ऐसा दिख रहा था. That's
ऐसा दिखता नहीं. This is not the way you can do anything. You have to solve question. You're not supposed to guess the question that this is my intuition, this should be the answer. Solve it.
Okay, sir.
Yeah. So when I say solve it, so it should be solved. Solve means the answer should be appearing at the end. Yeah, so horizontal range is not same. That's again incorrect. Tanishi, the range is not incorrect. I mean, you can't say range, you can say position.
Yeah, position, sorry.
Yeah. So range means you may start somewhere else. We are only throwing only one object. One is only moving in a straight line. So where is the range coming into a picture?
Sorry.
Okay, look at this answer now. You see, Manav, are getting anything? Kanu? कुछ समझ में आ रहा है?
Yes, sir.
Yes, sir. Try kar.
Yes.
Yes, Asika, what happened? Why not getting an answer?
Sir, I kept making some calculation errors, so I went for the second question.
No, don't go for second. Solve one only.
Okay, sir.
See, if something is colliding, it is the easiest of all questions. Always. Because the position we have to equate, and you should know that how to equate the position. It doesn't matter whether you know relative or not, doesn't matter.
Oh, okay, sir. Got it, sir.
Who told you that you are supposed to use a relative concept? No one said so.
Yes, sir.
So this is the height is how much? And this is how much? 3 meter. And I have to hit this point, right?
Yes.
If I make this, if see, I'm throwing something with UI and UX because I don't know what is U. And I have, okay, if I make this fixed, if this is the observer, then the one has to arrive at 2 to hit. So one will have velocity and 2 will have nothing. So the velocity of 1 is the final velocity in the frame of 2 as well. And acceleration of 1 will be G downward and A left. Because 2 is having acceleration right. Isn't it? And now it's very simple. I mean, it's the same thing. So to travel 3 meter in X, I will at UXT minus half A T square equals to 3 meter. That's simple. Where is the problem? And to travel 1.5 meter above, we have to at UIT minus half GT square equals to 1.25. And then there is a condition given that it is hitting downward, which means Vy equals to minus Vx. Isn't it? 1045 is how much? So when you are hitting in the downward journey, put a minus sign. Why? Because it will be negative. So 45 is 1. So that's the answer. So Vy is how much? Ui minus GT. Okay, and this is the ground frame, not in the relative frame. So in the ground frame, it is hitting. So I can add, and Vx will be Ux only, because this part is in ground frame, isn't it? And then we can equate it. So Ui minus GT equals to minus Ux. I mean, simply you can say Ux plus Ui. So basically the sum is GT. And the same thing will come here also if you add the equation 1 and 2, right? So if you add 1 and 2, you get Ux plus Ui into T minus half G plus A into is 4.25, right? So this is GT square minus half G plus AT square is 4.25. I think this can be subtracted. So 2 GT is I think G minus A, right? 8.5. And what is G? A is given how much?
1.5.
Every information should have been written, and then you have to figure it out. Figure it out that what we can do to get the answer. Even this is not required, but just to show that it's a relative means you can fix 1 point and then just write the motion of only 1 point. You're not supposed to think of motion of 2 points, only motion of only 1 point. That is sufficient. Is it? So is answer. Is this clear?
Yes, sir.
sir.
Solve second question. See, relative motion chapter doesn't mean that you are, if you're not getting into relative, just solve the way you want. There is no hard and fast rule of relative motion unless they say solve in this frame. Or you can also write the equation like this. You know how? Let me show you. R minus R naught ut plus half. I'm taking one as only moving particle, 2 is at rest. So to hit, how much I have to go here? R is 3 I cap plus 1.25 J cap. This is 0. And what is U here? Only U. So I cannot U equals to U. And what is your half A? Okay, so A is how much? Put a minus AI minus GJ. So this is question 1. I can write in component form or vector form. You can also write U as UXI plus UIJ. And then other equation is given to us. Okay. And what is given? That V vector is 45 with horizontal. So this information is given to us for only the particle which is performing the projectile motion. So you don't know how it is thrown, what is the angle. But for after time t, we can always write V vector equals to any U vector relation. And V vector is making 45 degrees. So it is like, this is U, which you have thrown, which you don't know. But I know that this is GT and this is 45, right? Isn't it?
Yes, sir.
And the entire time is GT. So we know certain answer, okay. So how to write this vector? Because you have to replace. So here, can you do something here? U sine theta plus V sine 45. It doesn't make any difference here.
So we can take U in terms of V and then rewrite that equation.
No, we have to use the relation, the 45 degree we have to use. So 45 degree, how to use? That's the question.
Sir, V cos 45 is equal to U U cos theta.
And that is always there. That is always there. The X component is always equal. Okay. But we have to replace UT in terms of Or maybe this is UX. This is UI. And okay, because it is 45 degrees, so both components are equal. Yeah, so now we got it. Because V is 45, so the components are equal. So Vy equals to Vx in opposite direction. So anyway, because the components are same, so we can recreate the vector because we know the x component. So this will become. So V vector is how much? Vx minus Vy j cap, right? And Vx will be same as Ux. And because the components are equal value wise, it is Ux j cap, right? The value wise. Then we write like this. Uxi minus Uxj and okay. Both are same value. So this is also Ux value. That's the whole idea. I mean, the idea is because Vx equals to Vy value wise in the downward direction. So that's I mean, eventually it will lead to the same answer. That Ux minus Uy, Ux plus Uy will be GT. This will come eventually. So from vector also we cannot replace. I mean, this is how we have to go on the component method. Okay, solve the second part. Question number 2. So anyone getting the question number 2?
Yes,
Sir,
Ajay.
that's
Every information given, you have to use it in one way or the other way. So this is a very old question, but still you will see that these questions are actually mentioned in the booklet because these questions are really good.
yes, sir.
So this will be the same answer because you have to convert it into I cap, J cap. So you have to add to U eventually as Ux, I, Uy, J, then separate the I term, J terms, you get the two equation and then use the third condition to get the answer. So anyway, you have to use the same method.
Sir, so in the first question, there is no like little thing that we can notice to make the question shorter.
Yeah, we can make it shorter. There is a thing. So you can see that the ball is observed in which frame? Frame of A,
Yes, sir.
and it is hitting the frame also, trolley also, right?
Yes, sir.
Which means in the frame of A, the velocity of O must be along the line joining the trolley and the ball.
Alright. Yes, sir.
So that is information.
Okay, sir.
So it is very simple, no? Because if something is hitting, then the net velocity must be in that way.
Yes,
So
sir.
the component perpendicular to that must be 0. This is what we discussed, right?
Yes, sir.
So think about it.
Okay, sir.
So 2 is particularly useful if you think in vector form, or the component form, or the relative form. If you think that way, it's easy. We know the condition for collision. When velocities are given and the line joining is given, we know how to do it. So think about it. So you want to try more or shall I solve now? Just you got the answer? Okay. So what is the question? I can see one diagram first. Is a okay. Tell me what is the question? I need to read. On a frictionless horizontal surface, assumed to be extra plane, a small trolley. So its velocity is making what angle? Phi, right? So to hit, you must be throwing like this, isn't it? Such that this line okay. So this is phi. So you must be throwing something like this. As V or U. So what is the condition for collision, if you remember? Condition for collision is if I make
We equate the point of collision.
yeah, I can fix this object A. So the particle will have two velocity, one U like this and the VA like this, correct? And we know that the net component must be along the line joining the particle O and A, right? So U12 must be like this, isn't it? What is given here? So that we know, no? So what is the angle theta? Theta is the angle made by the U12 with x-axis, which is 45 only. Correct? What is the angle made by this vector with x-axis? Read the question.
45, sir.
45.
So that's given to you. And phi is how much?
5/3.
60 degree.
So this is 6, this is how much? 15 degree. And what we know from the theory, from the law of collision, which component must be equal? The
Parallel.
perpendicular. Parallel.
That should be equal and opposite. Sorry, perpendicular should be.
So your job is done. So VA cos 45 must be equals to how much? 90. This is 75.
Yes.
So can we say U cos 75 is same as VA cos 45. Hello. Because this component must cancel out each other, isn't it?
Yes, sir.
Then only it will go this way. And cos 75 we can derive, it's not difficult. Cos 90 minus 45 plus 30. That's easy. VA is given √3 minus 1 for the obvious reason you know. So U cos A cos B √3 by 2 minus sinus and B 2 √2. So the answer is 2. Over.
Sir, or we can even write displacement equation in X and Y component.
Yeah, right on. No problem.
So like the one which I had sent you, in there I just had to put theta equal to 60 degrees and we would come to
Theta equals to?
theta. Like my theta is, I took phi to be theta. My notation was a bit, so I just had to put that equal to 60 degrees,
Okay.
which is given actually, because since we know that the angle, the relative vector makes is 45. So we know the phi is 60
No,
degrees.
you would not know. Now you know.
Sir, I knew that, I just hadn't used it there because like I just directly saw it.
No, you didn't solve. Where you solve?
So there, if I just like, now I know that theta is 60 degrees because
Okay.
that information is given. I hadn't
Ah,
used that before.
okay. No, then fine. So you got the idea? I hope so.
Yes.
What is the next question? So your next question is, go down in ALP. Question number 14. 1998. And think about it. And those who like the way there's always like taking the ground frame value D and D, right? And then you can say D equals to U cos phi into T. And then D plus VAT equals to U sin phi T.
Yes, sir.
And you can replace D. So U cos phi T plus VAT equals to U sin. So VA equals to, oh, sorry. Correct, no?
Yes,
So
sir.
V is given √3 minus 1 and phi is 60 degree. So sin 60. Every question, see, a relative motion is not at all required again. As a beginner, if it is clicking your brain that how to use it, use it. Yes, every question of kinematics can be solved in the ground field.
Sir, in the ALP, you said the 14 sum, right? 1998.
Yeah. If the relative clicks, it's a really good method. If it doesn't, then you have to struggle a bit. That's it. Condition for collision is very important concept, not only in this chapter, but maybe you may come across in other chapter also, in center mass also. So the idea will be there. So the idea is, if we are learning the relative motion, then we should use it, because anyway we can solve the question without this chapter. But what's the purpose of learning this chapter? To understand this chapter, to use the idea of this chapter. Because in many situations, the idea of a relative is really effective and fast. Yeah, only through practice. So
Sir,
yes.
sir, in the first sub question, the distance travel we have to find with respect to observer in ground frame or the box frame.
For that, I have to read the question. What question is saying?
I don't think so they have mentioned, but in the question they have given the US speed with respect to box.
No, that is fine. But if they are asking nothing, then it's ground frame, I think.
Okay. Sir.
But you have to decode the language, I think. So in that question, I think the best way is to take the box as a fixed object, right?
Yeah.
And along the plane, the acceleration component will match for both.
Yes.
So in that frame, the again a relative along the plane will be 0, not in ground frame. So think about it.
First part is doing the second one.
Second one you can do mentally also.
Oh,
If it clicks, it's easy. If it doesn't, maybe difficult. But it's only one line question.
okay.
So a relative something which is like either it clicks or doesn't. Now how it clicks? So if you have solved a lot of questions in past, if you find comfortable with component thing, vector thing, you will find it's really easy.
Sir, done, sir.
So got the both answer?
Yes, sir.
Send me the solution, let me see.
Okay, sir. Sir, the second part though, when you like told the I mean like how to approach it, that time it clicked.
No problem. If it clicks, it's really good.
Okay, sir.
Just you got the answer?
This one I got.
Which one? Okay, you got the answer for both part, right? Perfect.
Yes, I got the first one, thinking about the second.
Same thing. Hmm. Right. So then now there are three types of problems which are left, which is rain man, river boat, and wind airplane, and velocity of approach. So these three or four variety. So velocity of approach is not part of JEE from kinematics part, but that's very, very important and crucial concept if you want to understand the constant
right.
relation in laws of motion. So the actual use is in rotational dynamics or in laws of motion. When we try to write the constant, basically it's there's a concept of constraint relation. So in engineering, we have a separate chapter which is called constraint. Okay? We don't study as a part of kinematics or part of laws of motion, part of rotational dynamics. It is itself is a concept, okay, which we use to solve a large variety of problems. And constraint is very essential for the question related to the not just laws of motion, but also work, energy, and power. Constant is also related to the question based on the impulse momentum theorem. So constant is something which you have to learn anyway. And you will get the first glimpse of constant here. But what I'll do is I'll try to explore the entire constant through that idea, which can be used in any chapter. So we'll try to develop some generalized thinking process. Question is done. The question which I just gave, 14th question, question number 14.
In the
ALP,
Riemann sheet.
no, ALP 14th question done.
Acha, ALP.
What you have been doing? Something else?
No, I thought the new sheet you were talking about.
No, ALP 14 question is done. Yes or no? Huh? Yes or no? No. Not done.
B part I'm doing.
Okay. Do it.
Done.
Send me solution. So I have sent some question, which is based on the river boat, on normal question, rain man. These you can start trying. So next lecture I will take those questions. So we'll discuss the problem and some theory also. But meanwhile, you can try. And what else you can solve? You can solve from middle of some questions. Just so you can solve question number. I'll mention the number 1.1. Of course, you can solve all, but the question of relative I will just mention 95. So these can you solve with the idea of a relative, or even normally you can solve. That's it. So practice this sum, try to understand the idea. Just don't see the idea of getting the answer and you're being happy. Okay. Try to understand why you're getting the answer. The why should be very clear. Why you're getting the answer. More than answer itself. The why. Okay, guys.
Yes.
Just a second, sir.
Yes, sir.
Screenshot.
So practice and we will meet again. But I think your boards will start from what? Which day?
Friday.
Yeah. So I think we this
Tuesday.
week, next week you will not have any lecture.
Okay.
I think how many of you having like time in the
Last
next week?
board exam is on 13th.
No, last is 13, but now you need time for boards, right?
Ha.